The Earth is viewed from space to emphasize the interconnectedness of global systems. This perspective highlights the interactions between various planetary processes. Understanding these interactions is crucial for comprehending planetary boundaries. Planetary boundaries define the safe operating space for humanity on Earth. The greenhouse effect is a natural process where certain atmospheric gases trap heat. Increased concentrations of greenhouse gases enhance this effect. This enhancement leads to a greater amount of heat being retained in the atmosphere. Consequently, the Earth's average temperature rises, resulting in global warming. Deforestation in the Amazon leads to significant biodiversity loss. The destruction of habitats threatens countless plant and animal species. Deforestation releases large amounts of stored carbon dioxide into the atmosphere. This carbon release contributes to global warming and climate change. Ocean acidification is the ongoing decrease in the pH of the Earth's oceans, caused by the uptake of carbon dioxide, CO2, from the atmosphere. As atmospheric CO2 levels rise, the ocean absorbs more CO2, leading to a series of chemical reactions. These reactions result in a reduction of carbonate ions, which are essential for marine organisms like corals to build their skeletons and shells. The reduced availability of carbonate ions causes coral bleaching and hinders coral growth, ultimately leading to the collapse of coral reef ecosystems. Plastic pollution in the ocean is characterized by the accumulation of plastic waste. This accumulation leads to the formation of large garbage patches on the ocean surface. These patches consist of various types of plastic debris, including microplastics. Marine life is severely affected by plastic pollution through entanglement and ingestion. Ingestion of plastics can lead to malnutrition, internal injuries, and death in marine animals. Plastic pollution disrupts marine ecosystems and poses a threat to biodiversity. Water scarcity in arid regions presents significant challenges for agriculture. Limited water availability restricts crop growth and livestock farming. This scarcity impacts food production and economic stability. Human populations in these areas face difficulties accessing potable water. Water scarcity can lead to health issues and displacement of communities. Landfills are a major destination for discarded food waste. Decomposing food waste in landfills generates significant methane emissions. Methane is a potent greenhouse gas contributing to climate change. Food waste represents a loss of valuable resources, including water and energy used in production. Reducing food waste can mitigate methane emissions and conserve resources. Sustainable agriculture focuses on farming methods that minimize environmental impact. Crop rotation is a key practice involving the cyclical planting of different crops. Reduced tillage methods aim to minimize soil disturbance during planting and harvesting. Integrated pest management, IPM, employs strategies to control pests with minimal chemical use. These practices collectively promote soil health, biodiversity, and long-term productivity. Solar farms are designed to convert sunlight into electricity on a large scale. Photovoltaic, PV panels, are the primary component absorbing photons from sunlight. The absorbed photons excite electrons in the semiconductor material of the panels. This excitation generates a flow of direct current, DC, electricity. The DC electricity is then converted to alternating current, AC, for grid distribution. Wind energy is harnessed using wind turbines, which convert kinetic energy into electricity. As wind flows across the turbine blades, it causes them to rotate, turning a generator inside the nacelle. The generator converts the mechanical energy of the rotating blades into electrical energy. This clean electricity is then fed into the power grid for distribution to homes and businesses. Geothermal energy harnesses heat from the Earth's core. Geothermal power plants tap into underground reservoirs of hot water and steam. This hot water, or steam, is then piped to the surface. The steam rotates turbines connected to generators, producing electricity. The cooled water is often returned to the reservoir to maintain sustainability. Hydroelectric dams harness the kinetic energy of flowing water. Water is channeled through the dam, passing through turbines. The force of the water rotates the turbine blades. The rotating turbines are connected to generators. Generators convert the mechanical energy into electrical energy. This electricity is then distributed to power grids. Energy-efficient building designs aim to minimize energy consumption. Smart buildings integrate technologies to optimize energy usage. Smart thermostats regulate temperature based on occupancy and preferences. These thermostats learn patterns to automate energy-saving adjustments. LED lighting provides efficient illumination with lower energy requirements. Collectively, these features contribute to a building's overall energy efficiency. Electric vehicles, EVs, are a core component of sustainable transportation initiatives. EVs utilize electric motors powered by rechargeable batteries instead of internal combustion engines. This shift reduces reliance on fossil fuels, a major source of greenhouse gas emissions. Charging infrastructure, including public and private charging stations, supports EV adoption. Widespread EV use contributes significantly to cleaner air and a reduced carbon footprint. The circular economy aims to minimize waste and maximize resource utilization. Recycling plants play a crucial role in recovering valuable materials from discarded products. These materials are then processed and transformed into new products, reducing the need for virgin resources. This process helps to close the loop, promoting sustainability and environmental conservation. Sustainable consumption involves making purchasing choices that minimize environmental impact. This includes reducing overall consumption by buying less and prioritizing needs over wants. Supporting local businesses reduces transportation emissions and supports the local economy. Choosing eco-friendly products ensures that items are produced with minimal harm to the environment. Sustainable fashion focuses on minimizing environmental impact throughout the textile life cycle. One key practice is the use of organic cotton, grown without synthetic pesticides or fertilizers. Reducing water consumption is another crucial aspect of sustainable textile production. This can be achieved through innovative dyeing techniques and water recycling systems. Minimizing waste involves strategies like using fabric scraps and recycling textile materials. These practices collectively contribute to a more environmentally responsible fashion industry. Green building designs integrate sustainable practices into urban environments. These designs often incorporate green roofs to reduce heat absorption and manage stormwater. Rainwater harvesting systems are utilized to conserve water and reduce reliance on municipal supplies. The integration of these features promotes environmental sustainability within urban settings. Carbon capture technologies are designed to mitigate CO2 emissions from industrial sources. These technologies involve capturing CO2 directly at the emission source. The captured CO2 is then separated from other industrial exhaust gases. After separation, the CO2 is compressed for transportation. The compressed CO2 is transported to a storage site. Finally, the CO2 is stored securely to prevent its release into the atmosphere. Reforestation is the process of replanting trees in areas that were previously forested. It aims to restore degraded or destroyed forests, often due to deforestation or natural disasters. Reforestation involves planting native tree species to promote biodiversity and ecosystem recovery. These efforts help to sequester carbon dioxide from the atmosphere, mitigating climate change. Reforestation also improves soil health, prevents erosion, and provides habitats for wildlife. Precision farming utilizes advanced technologies to optimize agricultural practices. Drones are deployed to capture aerial imagery of fields, assessing crop health and identifying problem areas. Sensors strategically placed throughout the field monitor soil conditions, moisture levels, and nutrient content. Data collected from drones and sensors is analyzed to inform targeted interventions. This data-driven approach enables precise application of water, fertilizers, and pesticides. Ultimately, precision farming aims to maximize resource efficiency and improve overall crop yields. Vertical farming is an innovative approach to agriculture. It involves growing crops in vertically stacked layers. This method is typically implemented in indoor environments. Indoor farms optimize space utilization compared to traditional farming. Crops are cultivated in a controlled environment. This controlled environment can lead to increased yields and reduced resource consumption. Alternative proteins are being developed as sustainable substitutes for traditional meat sources. Plant-based meats are created by processing plant materials to mimic the texture and flavor of animal meat. Cultivated meat, also known as lab-grown meat, is produced by culturing animal cells in a controlled environment. These technologies aim to reduce the environmental impact and ethical concerns associated with conventional animal agriculture. Research and development in this field are focused on improving taste, texture, and production efficiency. Sustainable packaging focuses on minimizing environmental impact throughout its life cycle. Biodegradable plastics are a key component, designed to decompose naturally over time. Compostable packaging offers another eco-friendly option, breaking down into nutrient-rich soil. These materials reduce reliance on traditional plastics derived from fossil fuels. Sustainable designs prioritize recyclability and reduced material usage. The goal is to create a circular economy where packaging materials are reused or safely returned to the environment. The sequence showcases diverse individuals worldwide, actively participating in sustainability initiatives. These actions address a range of environmental and social challenges. The montage aims to inspire viewers to engage with sustainability efforts. It encourages viewers to take personal responsibility and contribute to positive change. The overall message promotes the idea that collective action can make a significant difference.